How's it going? So we're going to demo our serial and parallel communication module that we implemented with a RAT wrapper. Basically what's going on is we got two basic subtract programs running on each board, and basically we just have the option to either write or send the data over what's currently on our LEDs to the other board, and each board has that option to either output it to the LEDs or use it for something else in the future. I mean, it's really up to the program or how you design the RAT wrapper with this, but it's pretty cool. So I'll show you what's going on here. So let's say we got, we're doing our basic program, whatever it is. For this case, it's subtract. We want to send that over to the other board and write it. So we'll just push this button right here. It gets sent to the other side to the module, and that module basically writes it to a separate register and sets it aside. For the meantime, it's basically just on, it's the current state what it was just last sent. It only gets overwritten once we push that button over there. But if we come over here, we have the option to either display your own data on your side or the other board's data. Oh, there we go. So as you can see, it's pretty cool. And you can say on data and write data just simultaneously. So that can be done under a program control. It doesn't have to be external. It's just a way for me to show you guys how this thing kind of works. But do the same thing for this way. So right now, the last data that was sent over here was this value, and we're going to change it up over here. Let's just do this. Push this button to send it over. No, sorry, this button to send it over. Come over here, we have the option to either view your own LEDs, the output, of your own inputs, or we can see the output of the other guy's inputs right there. Cool. So another example, I guess, just really clear this up. Let's do FF minus FF. Sorry, FF minus 1. And we'll send that over with this button. And we'll push this right here. And there you have it. It's pretty cool. So, duplex communication on the RAT MCU is now achieved. A couple things to note is this is the master node we're running right here, and so basically making this board in sync with this guy. The modules, basically we sent the onboard clock to a clock divider within the DPS module, and that's being sent over to this board, and it's using that rising edge to sync the data coming in and out. So it's pretty simple in that aspect. Able to run the clock rate up to actually 40 megahertz, and everything still ran kind of cool and perfectly. So the only issues really with this whole thing is that this board actually has to have a resistor in parallel with the RX signal, and that's to be tied to ground. For some reason, it doesn't clip off any pulses. It doesn't seem like more of a clock edge when it comes in, and it actually kind of decays a little and doesn't discharge right away. So you have to filter that off in order so it doesn't read an extra bit that's high when it's really not. But data coming in this way, we didn't have to add a resistor at all. It's data just never really gets destroyed at all. It gets sent perfectly fine over here, as you can see. So pretty cool. We can run RAT MCU programs on both sides and send data, whatever it may be, to the other sides and do with it whatever you really want to. So that's about it. I'll post more examples in the future. Thanks for watching.